Okay, so I realized when I started rendering the last video that what I wanted to talk about in main concept 4 here, I kind of already mentioned back in uh, concept 3. But I also felt like this wasn't 100% clear. A little messy with kind of writing over here in blue, and some of you might have wondered where did this 2.5 come from, and what's this? So let me try to make it a little more clear. Let's say we have two vectors. One is vector A, going like that, and the other is vector B, maybe going like this. What's A plus B? And for illustration, let's just say the magnitude of A is 5 meters, and the magnitude of B is maybe 4 meters. So what's A plus B? So you might think 9. If these are parallel, then yes, you could do 5 plus 4 is 9, but they're not. Really, how it works is you would bring B over like this, call this the tip to tail method, and the magnitude is you start at the beginning of the first one, the one you're adding here, and then you go to the end of the second one you're adding, and this is the sum. You can see it's going to be less than 9. It's even looks like less than either of the other two. So what we need to do, let's just get rid of this, is break these up into components. So let's do that, and there's a couple ways to do it. Let's do it in blue. So let's start with A. We want to break them up into an XY axis, XY plane. So let's break A into its X component. So the X component of A has to be parallel to the X axis, in other words, horizontal. So we'll call this AX. And the Y component has to be parallel to the Y axis, so vertical, and we'll call it AY. And then over here, let's do the X component. It's going that way, call this BX. And down here is BY. Right? Now that we have some parallel vectors here, we can just add mathematically, like 5 plus 4 is 9. Whatever AX and BX are, we can just add together mathematically. So we can go AX plus BX equals, we'll call it CX. And we can go AY plus BY, we'll call that CY. And I don't know if I'm going to be able to do it. Let me try here. Nope. I was going to try to drag just AX down. I'll just redraw it. So if we take AX, which looks about like that, and we take BX, which goes like that, we can see that, this is BX, we can see that the sum of those, whatever those values are, which we can get from SOHCAHTOA, this is CX. So it looks like it's going in the positive direction. And then we can take AY, which looks like that about, and BY, which looks like that about, and get CY, which would look like that. CY. Start the beginning of the first one and the end of the second one. And now to get C, oh, C is going to be this, first off, the length is cx squared plus cy squared. Where'd that come from? Well, we can make a new triangle. We got cx looks like that, and cy looks like that. And so the resultant is that c, it's the magnitude, it's the hypotenuse. So to find the length of this, we just do Pythagorean theorem, and then we could also do tangent stuff, inverse tangent of stuff, which I'll show an example from the book later. And we're good to go. So this is what you do when you add non-parallel vectors. You add the like components first. You add the x components and the y components. And if you had 25 different vectors, here we only have a and b, so that's 2 vectors. But if we have 25, you just go ax plus bx plus cx plus dx plus ex plus fx plus gx blah 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 equals whatever x. Ay plus by plus c plus, that's a plus here, plus by plus cy. Whoa, where'd all my lines go? Ay plus by plus cy plus dy yada yada equals total y, and just go from there. So that's how you handle vectors. Alright, next is 5. Main concept 5. And that's basically saying the negative of a vector is the anti-parallel of the vector. Pretty simple. It's going to take just a couple seconds. That's horrible. If this is A, then negative A is just 180 degrees in the opposite direction. Right? So if this is B, then negative B would be, whoa, about like, oops, it's not quite, it's about right there. This is negative B, 180 degrees in the opposite direction. That's it. So if you have A minus B, you could do A plus negative B, which means you take your A here and you just add it to this, and then you just do vector addition like we did back in number 4. Just do this, all the steps, but for these two. Pretty straightforward. And finally, we got cross product. This is not super straightforward. In fact, hopefully I can fit this in. You know what? I don't think I'm going to be able to fit this in the next 7 minutes. All right, I'm going to try. We're going to go crank here. So cross product. You can multiply vectors. We just got done talking about adding vectors. You can multiply vectors. A cross B is really A times B. There's another way to multiply vectors. It's the dot product, but we don't really use that, and so I'll just briefly mention it in one of the sample problems I do. But cross product is A times B times the sine of the angle between them. And so if you just, if you have A like this and B like this, and there's an angle between them, you just do the length of this times the length of this times the sine of the angle between them. And as you know, sine of 0 equals 0. So if the angle between them is 0, in other words, if they're parallel, the cross product is 0. But if you have sine of 90, that's 1. And sine goes from 0 to 1. 0 is the smallest sine will ever be, and 1 is the largest sine will ever be. So if you have perpendicular vectors and you cross product them, you'll get the biggest result possible. And then any angle smaller than 90, you'll get a smaller result. So in notes, the cross product of parallel lines is 0. I need to get a new tablet because this is not working as well as it used to. The cross product of perpendicular lines is maximized. Okay. Now how do you do the cross product? Well, let's say we have two vectors. Let's say A is a three-dimensional vector. So we're going to break that up into its three components. An x component, and that's in the x direction. And little notation here. Here's our axes. Okay, this is the x-axis, which we denote with an little I vector. This is the y-axis, and we denote that with a little j vector. And this is z-axis, and we denote that with a little k vector. These are called unit vectors, and they just tell you what direction. It's, yeah, I can go into more detail about that, but it's not super necessary. So I'm going to put I hat here, just to let us know that this is going in the, because this AX eventually will be replaced with a number, a magnitude. Say it's like 5. So what direction? Now that A of X is 5, we don't know it's in the X direction. So how do we tell? Put the little I, and that I says, oh, that's going in the X direction. Okay. Plus AY in the J direction, plus AZ in the K direction. And then a B vector, which we can say BX in the I direction, plus BY in the J direction, plus BZ in the K direction. Now, what's A cross B? Well, if you just have two numbers with two vectors with an angle between them, you could use this formula. But if they're broken up into components already, like this is how you handle it. You don't need the sign of the angle because everything is perpendicular. If you have questions about that, just ask me in class. But really what you do is you just multiply them out. AXI plus AYJ plus AZK times BXI plus BYJ plus BZK. And 2 minutes. Well, let's just go right through it. Well, no, I'm going to do an example of this. But I think I won't stop here, but I won't distribute this. Basically, you distribute, right? You do AX I hat times BX I hat, right? And then you do AX plus AX I hat times the next term times BY J hat. But the thing to notice is if you do I hat times I hat, those are two parallel vectors, and the cross product of a parallel vector is 0. So this disappears, whereas I hat cross J hat doesn't disappear. And this video might go a little longer than 15, I'm sorry, but that's okay. So all the parallel ones will disappear. So when you do AYJ times BYJ, it's gone. AZK times BZK, gone. But you're going to have a bunch of other ones. You're going to have an IJ, you're going to have an IK, you're going to have a JI, you're going to have a JK, all that. So how do you handle those? Well, let's just write them out. If you have an I and a J, then that's going to equal K. How do I get that? I use the right-hand rule. What you do is you take your pointer finger and you point it in the direction of the first one, so in this case I, and then you take your middle finger and you make a 90-degree angle. It's kind of hard to see on here, but this is a 90-degree angle between them. So it's kind of like you point your pointer finger towards someone, and you bend your middle finger so that it's perpendicular to that. If you need me to show you in class, just ask. And this, your thumb points straight up so that it's 90 degrees between here, between your pointer finger and your thumb. That points in the direction of the cross product. So you can see if you take your pointer finger and you go that way, in the I direction, and then you take your middle finger and you go point it up in the Y direction, then your thumb is going to point out of the page. Basically, your thumb's going to go this way. You might have to bend your finger a little bit. It's kind of hard to show you this on here. Please ask me in class. I can give you a visual. But anyway, your thumb points in the positive Z direction. And if you want to try this out for the others, you should get I and K will give you negative J, meaning your thumb will point down in the negative J or negative Y axis. You should get J I will give you negative K, J K will give you I, K I will give you J, and K J will give you negative I. So if you've seen this before and this is straightforward, good. This is just a little review. If you need some reassurance on some of this stuff, just ask me in class, and it's a little more productive or a little more efficient to show someone this in person. But I will do an example from the book with numbers, and it'll make it a little more straightforward. Alright, 17 minutes, a little long, but at least I didn't have to make another video. Alright, see you next time.